What's happening, folks? Geologist Philip Prince looking out over the Himalayas in Uttarakhand, northern India. Mountain peak up there at the top of the screen is about 20,000 feet above sea level, about 6,000 meters. And down at the bottom here, got a little village called Dharali that's about 12,000 feet below that mountain peak. Huge mountains in this part of the world. This is older Google Earth imagery, and Dharali actually no longer exists. There is a chance that you saw a video of this sometime in the summer of 2025. If you were to type in Dharali cloudburst, YouTube, Google, anywhere, you will receive an endless supply of what's actually some of the most shocking geologic video you're going to see anywhere. I would suggest watching with caution, but the videos are very clear in showing that quite suddenly, the little town that you're looking at down there basically ceased to exist. And what we've got on it right now is some satellite imagery taken after the event. What you're looking at there is essentially we'll color it in with brown here. The extent of all of the mud, boulders, whatever else that came down the mountain and ended up burying this town. There were several waves of it, but really just the first couple of waves did most of the work. So quite literally, you had a settlement down here that sort of without warning, just vanished one afternoon. So what went on here? Something that you see actually quite a bit in this part of the Himalaya. You got monsoon precipitation here. If you put monsoon level rainfall on a steep landscape, you're going to have a lot of things happen. But in this particular case, there is a specific cause for this particular event. In terms of identifying that, that's kind of tough to do without things like the satellite imagery that I just showed you there. And for much of the past several months, this entire landscape has been completely covered with clouds because it is monsoon season and all of that moist air comes in off of the ocean and rises up on this steep topography and produces hard rain and nearly constant cloud cover. But in September, kind of mid-September, ended up getting some new satellite imagery showing this landscape, and it actually gives you a chance to see what happened here. One of the initial theories was that way up there high in the mountains, there was some kind of like glacial lake up there or something like that. And that glacial lake broke its natural earthen dam, overflowed, something to that effect, and then sent this terrible flood coming down the valley there, which would have ended up wiping out Dharali at the bottom. As it turns out, that was not the case. That is something also that happens quite a bit in the Himalayas just because of the topography here. But in this particular case, you can go up here to the top of the mountain and see pretty clearly that there is not any sort of glacial lake up there. In fact, it's quite dry. There is glaciation and less every year, of course, up here on the high peak. Got accumulated sediments down here, what we call like glacial moraines, where glaciers of the past sort of push material down towards you if you're looking at the screen here. But it's quite a dry place, and we'll actually take that satellite imagery away there. Go back in time a little bit with Google Earth here. And you get a sense of that being again pretty much a dry mountaintop that does have glacial ice on it. You can have landslides and avalanches that come off of ice and entrain a lot of material coming down slope. So that's always a possibility. But again, in this case, you don't have any evidence of that. In fact, this new satellite imagery is remarkably clean, right? You really don't see any huge in your face scar anywhere on the mountain. And if we take a look at the after effects here, it looks pretty much exactly the same as it did before the event happened. In fact, the only real big difference that you see is if you keep your eye right down there where the town is. This is the new imagery where it's buried in sediment. And in the old imagery, you can see the town as it once existed. But again, there's remarkably little change to the landscape. Sort of a mystery here as to where this absolutely incredible destruction that came down the mountain, descended several thousand feet, wiped this town out. Where did it actually come from? So if you look close here, you can actually answer that question. And again, this is one of the best examples of how you would use satellite imagery. First of all, to figure out what happened here, and then to try to learn what you can take away from it, and see if you could potentially avoid a problem like this in the future. You zoom in here, right up here at the very top of the mountain, centered in the screen. There's going to be a couple little points of interest here. You got one right there. You got one right there. So watch at the ends of those arrows. So that's before the big disaster that buried the town, and that's after. Again, there's not a whole lot of difference there, but you can see that there is a little bit of color change in those locations. Here it looks like some material kind of flowed down like that. And you see something similar right over there, right? So what's going on here, and how are those two tiny little things possibly the cause of this incredible calamity that buried this town and half the world watched happening back in the summer? All comes down to that monsoon precipitation and indeed heavy rain. This was called a cloudburst type of event that was a contributor to it, but it's what that heavy rain does to soil in terms of saturation. And it also involves just how mountain drainages, meaning mountain streams and rivers like this, actually operate over time. If you look at this overall landscape, it's got plenty of these sort of scars on it to begin with coming down the slopes. And if you think about what those are, they're older landslides that deposited material down in this channel over time. And it's the sort of geologic duty of that channel to slowly but surely, again, over time, carry that material away down the slope and into the big river. And in this particular case, you can zoom in on the Google Earth imagery. We won't do it here. And you can see that there is a huge amount of that material that's come down from the slopes that is stored in that drainage that's coming down high in the mountain and right out there onto Dharali at the bottom of the hill. So what does this look like? These are huge versions of the debris flow style landslides that I end up talking about quite a bit on this channel. Let's see, we'll draw ourselves out some kind of representative steep mountain topography here. A place like the Himalayas, you have very active tectonic uplift, got monsoon rainfall, incredibly steep, rugged topography, something that we don't really see in the Appalachians, even in the Rockies or Cascades or something like that in the United States. That's sort of a step down in terms of the physical scale of the mountains and also some of the crazy things that you see in terms of mountain behavior with really heavy rainfall on it, like we saw here with this event. So Dharali itself would have been sitting right down here on this sort of like it's a little teardrop shaped kind of feature. Need to put a big river down there. If you're in such a steep part of the world as this, frequently you're going to end up building along rivers just because that's really kind of your only option, right? So we'll get our little town sketched in right there. And then need to add in a few details on the slopes here. So that whole idea of these really steep mountain slopes pouring material down into this stream channel over time, really important one, right? So you can think of the stream channel here as sort of like the drain almost that is carrying all this rock that's coming down off the mountain down to the river so it can be carried away. It's how geology works. Water and gravity on Earth's surface is pretty much what makes the whole thing tick, right? And this is just a very extreme example of that. So you end up with quite a lot of accumulated material down in this channel here. And then on top of that, there is presumably even older material. A lot of this is really coarse, boulder rich, big accumulations of rock. It's not like pebbles and things like that that you would find in a stream in a quieter landscape, although you would find pieces of sediment of all sizes here, right? And in kind of more peaceful times, most of that material is just going to be sitting down there with this really small stream flowing across it. And that small stream's not going to be large enough to move any of that material away, right? So it's just going to be waiting, if you will, for a big event to come along and essentially sweep up all that accumulated material and take it down to the bottom of the valley. Now, how does that happen? Water flow alone can't do that. Just water-based flooding doesn't have the energy and it doesn't have the ability to really get down into that accumulated material to the depth that you would see with a more landslide type process. And a debris flow landslide is essentially just a really long and skinny landslide that starts quite small. So you'd be way up here, right? Kind of way at the very top of the mountain. You start a little landslide there. But with saturated soil, anything that landslide touches is going to essentially lose all its strength and be added to the landslide. So it's kind of like a big snowball coming down a hill you might see in a cartoon or something like that. It gets bigger and bigger the further it travels, and by the time it's at the bottom of the mountain, you've ended up basically raking all of that accumulated material from who knows how long of a time period out of that channel and then dumping all of it very quickly down there into the river valley and ending up, this absolutely gigantic deposit looking something like that. And the reason that so much material comes down at once is that you're looking at a process that basically cleaned out all that accumulation and got it moving all in one event, right? So you took the overall effects of a pretty lengthy period of accumulation of material in that little stream valley, and by starting a landslide high at the mountain under these saturated conditions, these monsoon rain events, who knows how much precipitation you might see at high elevation. We would do it by inches here, of course, in the US, inches per hour of rainfall. So you'd be looking at, maybe 10 centimeters per hour of rainfall for a sustained period or something like that. Once you get that saturated soil moving that way, clear it all out of there. The end result, is kind of this empty scoured channel on the way down, and all of the material that used to be sitting in there is now burying that town at the bottom of the slope. This has an interesting effect of backing up the whole river. If you put that much sediment down there in the valley, it actually dams up the flow on the river. You can have an additional problem with that if you back up too much water. That's going to come cascading out of there in a big sort of natural dam failure, cause flooding downstream. The list goes on and on. I don't know if that happened in this particular case. This event really sort of fell out of the news. The video was so extreme, circled the globe many times, but I think as the sort of the mystery of where this thing came from ceased to really intrigue people, and it also didn't have any answers because we couldn't get satellite imagery from the top. It sort of fell out of the news cycle. But suffice it to say, again, with that big rolling snowball analogy, this is an event that, like so many debris flows, it started really, really small. You don't need a big catastrophe up there high on the mountain to cause something really incredible to happen down at the bottom. All you need is saturated soil, which the monsoonal precipitation gives you, and some kind of a little landslide up there to start it out, right? So you're again not looking at at water flooding per se. This is something we saw very clearly in the Appalachians with Helene about a year ago. You get the soil wet enough, it's going to act in very unusual ways. So when you come back to the imagery here, yes, indeed, that tiny little scar that's right in the center of the screen there, which itself is really, really small compared to that big deposit of the material at the bottom of the mountain. That little scar starts off a chain reaction, and it's that chain reaction that ends up making its way all the way down and clearing all that material out the whole way down to end up burying the town as we saw happen there. That distance that I drew the line over there, it's about 5 miles, just shy of 5 miles, almost 8 kilometers. The descent that the actual landslide debris flow path covered was something like 7,000 feet. So it would be like 2,200 or 2,300 meters of elevation drop from top to bottom. So again, an incredibly huge event, something that we don't really have the ability to visualize here in the Appalachians because we don't even have any mountains that are 7,000 feet above sea level here. So you could take the highest peak east of the Mississippi River in the U.S. And comfortably fit it inside that area. So a very powerful landscape here, and one that unfortunately from time to time just does this sort of thing. This is not avoidable. Were there actually a glacial lake high on the mountain there? Yeah, you could monitor the condition of that. You could see if it looked like it was close to overflowing. There might even be, depending on its size, possible engineering solutions to try to get something up there to drain it. It would be very hard to get any equipment that high on a peak. But if you know that an issue exists, you can at least be aware of it and try to keep tabs on it. In the case of these debris flows, where the actual cause of the disaster is so tiny and almost sort of random in the landscape, you really don't have an option like that. When folks are trying to figure out what happened here, the lake outburst idea, I think, really took hold just because of the physical size of the deposit that came out at the bottom of the mountain there. But again, by no means do you have to start big in a saturated landscape like the one that they had here. What can you do in a place like this, to avoid this problem? Sort of an interesting question in and of itself. Turn off these turn off these overlays here. Really, you just have to choose very carefully where you live. So the houses that are right here, they are on a kind of a convex part of the landscape, right? So if water fell on the landscape, it would run off in that direction. You got water coming down the channels or potentially these disastrous debris flows pass drainage off in that direction there. So this is a pretty good spot to live in, at least in a landscape like this. It reduces the chances of having some of these crazy impacts from an event like this. The case of Dharali itself, which sits, get those drawings out of there, right down here on, we'll maybe color it with, we'll do yellow. Prior to the event, it sat on this little teardrop feature at the mouth of that stream. All that teardrop feature is the remnants of the last huge debris flow disaster that happened here. So living there, despite it being a good place to live, kind of a convenient place to build in such a crazy rugged landscape, it's only a matter of time. I mean, it could be next year, it might be 10 or 100 years from now, but it's only a matter of time before that particular spot gets hit with something like this. And due to the physical scale of the mountains around here, whatever happens is likely to be quite large. So it's really impossible to safely live in a spot like that. Now, that's sort of challenging in places like this. There's a lot of generational sort of legacy communities. A lot of very important places historically have been in parts of the landscape like this. But you're sort of waiting, I guess, for the next event like this to come along. If you zoom in closely here on the little village, can see the way it's set up here. Got the channel coming around it. There have been efforts made here to sort of control that channel and sort of steer it in the right direction away from some of the buildings. If you watch the videos of this disaster, which again you should do with the understanding that they're sort of difficult to look at because you can actually see people trying to get out of the way. The layout of the town there is going to be very recognizable, and what you see happening really in the first wave of material that comes down. We'll try to do that in brown again. You see it coming down and sort of spreads out over the landscape, sort of like you see there. It has so much speed and momentum that it doesn't actually make the turn that the water channel does. And of course, when it moves like that, it absolutely smashes all the buildings that you're looking at right there. Again, with the eventual effect, after you have wave after wave of material come down, of having, just sort of the whole village completely buried by there. Even with the grainy satellite image, you can see that it's totally covered up with material. So thinking in these terms, if you wanted to safely build in a landscape as rugged as this, I mean, really your choices are going to be something like that, where you're almost using these spur ridges that are going to keep you out of the way of anything like future debris flows that might be coming down some of these steep drainages. If you go on Google Earth in this area, follow that river, you will see in numerous locations these little fan-shaped structures, kind of like that coming out into the river. And sometimes you'll see more recent rock material that's been spewed out onto them in recent events. They don't always have towns built on them, but this is just a fact of life. And certainly throughout this summer, there were plenty more huge debris flow incidents associated with monsoon rainfall in this part of the world. So give give this a look. It's worthwhile to watch the videos, and it's worthwhile to look at where this place is just in the Himalayas, just in terms of seeing what the land looks like on Google Earth. Hard to know when we'll get new imagery of the location on Google Earth, so you can compare it at very high resolution. But when you do, even with that higher resolution, where this event started out, up here really high on the mountain, it's small and it's subtle, and it takes these very specific conditions to grow something small like that into this just absolute monstrosity at the bottom of the mountain. So if you wanted to check this place out, you can just type in Dharali, Dharali, and Google Earth will take you to roughly the right place. They actually put the thumbtack on it just a little bit upstream. But certainly give it a look if you check out those videos on YouTube. So hope you found this video interesting, and hope you check out the next one when it comes along.